We have 120 feet of fencing. You want to enclose a rectangular region. What are the dimensions that maximize the area? So you could do something like this. 50 plus 10 plus 50 plus 10 is 120. This will give you an area of 500 feet squared. Or you do something like this, and 40 plus 20 plus 40 plus 20 is also 120, and that will give you an area of 800 feet squared. So even though these have the same perimeter, they don't have the same area. So how do we get the maximum area? Well, the answer is a square where all the sides are the same. 30 by 30 by 30 by 30. So this also has a perimeter of 120 feet, but the area is 900 feet squared. And this is the largest area we can get for a rectangle with this perimeter. Would you like to see some math behind it? So we start with our arbitrary rectangle. We're going to call the width x and the height y. So the area is going to be x times y, and that's what we're trying to maximize. And the perimeter is 2x plus 2y equals 120. So let's play with this perimeter a little bit. Let's subtract 2x from both sides. We get 2y equals 120 minus 2x. Then after we divide everything by 2, we get y equals 120 divided by 2 is 60, and negative 2x minus 2 is negative x. So we know that y is equal to 60 minus x. Well, this is interesting because if we take our area, we can set it equal to x times, and instead of y, we could say 60 minus x. And we can distribute this. X times 60 is 60x, and x times negative x is negative x squared. So this is also our area. So if we graph the area, 60x minus x squared in Desmos, this is what we get. And you can see as the x gets bigger, we get a larger area. And then the maximum is this right here. The maximum occurs when x equals 30, and that gives us an area of 900. So going back to this, if we change these x's to 30, and then for y, we plug in 60 minus x, plug in 30 for that x, we get 30 as well. And this is the 30 by 30 square we had from earlier that gave us an area of 900. How exciting.